As you have already read, it is 3-dimension coordinate geometry. So, what is dimension? Dimension is nothing but the unit of measurement. So, 3 dimension means 3 unit of measurement, that is we have 3 axes, x axis, y axis and z axis. 3 axes are perpendicular to each other. So, a point represented by coordinate x, y, z. So, in 3D divides in a space and divides into 8 quadrants. 2D divides into 2 to the power 2, that is 4 quadrants. 4 quadrants, 1, 2, 3, 4. 1D, that is a straight line, that is 2 to the power 1, that is 2 quadrant. That is both sides positive. In 3D, it divides into 2 to the power 3, that is 8 quadrants. So, actually this is in 3 dimension. So, it divides a space into 8 quadrants. So, why it is 2? 2 is considered as is both height, one is positive and other is negative. So, every axis has 2 positive and negative sides. So, that means its powers of 2. So, 8 quadrants is obviously you can take it as a, that is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. So, 8 quadrants is positive, 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 negative. So, similarly that is 8 quadrants. So, most of the concepts in 3 dimensions are similar to 2 dimensions. Suppose we have 2 given points A and B having coordinates x1, y1, z1 and x2, y2, z2. So, distance formula is same as in 2 dimension, that is distance between A, B is equal to root over of x2 minus x1 whole square, y2 minus y1 whole square plus z2 minus z1 whole square. So, this is same as 2 dimension excluding the z coordinate. So, this is called its distance formula. Subsequently, the ratio formula. So, what is ratio formula? Suppose A point is x1, y1, z1 and B is x2, y2, z2 and P is a point x, y, z which divides in the ratio k is to 1, that is AP by PB is equal to k by 1. Now, x is equal to k into x2 plus 1 into x1 divided by k plus 1. Similarly, y is equal to k into y2 plus 1 into y1 divided by k plus 1 and z is equal to k into z2 plus 1 into z1 divided by k plus 1. Depending upon if k is positive, that is internal ratio. Internal ratio is like P is an internal point. If k is equal to 1, that is midpoint, and if k is negative, that is external ratio. External ratio is something like P is an external point. External point is like this, there is A, B and P is an external point. So, it is an external point and the ratio is external point, and here it is internal point. And it is called internal ratio. So, this is called ratio formula. So, both are in same as 2 dimension, distance and ratio formula. Now, what is the basic difference between 2 dimension and 3 dimension? So, one of the most important difference is in 2 dimension we say a line is inclined with some angle theta with x axis in 2 dimension. In 3 dimension we have, if a line, then we draw a line parallel to its and angle between x, y and z axis. The angles are say alpha, beta, gamma. So, in 3 dimension we have alpha, beta, gamma are called direction of a line. Whereas in 2 dimension it is called angle of inclination. So, angle of inclination in 3 dimension called as direction. Next, the cosine of direction, that is cos alpha, rather we represent as L m cos beta and n cos gamma, that is cosine of direction are called direction cosines, which is nothing but cosines of direction. In short form we represent it as DCS. So, direction cosines are represented as L, M, N. Now, what is the relation between the direction cosines? That is L square plus M square plus N square is equal to 1 always. That is cos square alpha plus cos square beta plus cos square gamma is equal to 1, where L is cos alpha, M is cos beta, N is cos gamma. So, first of all we have direction, then direction cosines. Next we have direction ratios. That is in short form is defined to be DRS, are numbers which are proportional to the direction cosines. So, direction ratios are numbers which are proportional to direction cosines. That means, if A is proportional to L, B is proportional to M, C is proportional to N, then L by A is equal to M by B is equal to N by C. So, direction ratios of a line are A, B, C. So, in 3 dimension we have 3 concepts, one is called direction, direction cosines and direction ratios. So, direction cosines are also direction ratios. So, as L is proportional to L, M is proportional to M, N is proportional to N. So, direction cosines are direction ratios, but the reverse is not true, but direction ratios are not necessarily direction cosines. So, how to change from direction cosines to direction ratios? As L by A is equal to M by B is equal to N by C. This is proportional also equal to L square plus M square plus N square, A square plus B square plus C square. As L square, M square, N square is equal to 1, this quantity is 1. So, L by A, M by B is equal to N by C is equal to 1 by root over of A square plus B square plus C square. So, L is equal to A by A square B square plus C square, M is equal to B by root over of A square B square C square, and N is equal to C by root over of A square B square C square. So, this is from conversion from direction ratios to direction cosines. So, direction cosines are direction ratios, but the converse is not true. So, that means if we are given direction ratios, we can easily convert into direction cosines. So, take one example, what is direction cosines and direction ratios of x axis. Now, first of all, what is the angle x with itself? X with itself is angle 0 degree. X with y axis angle is 90 degree, and x with z angle is again 90 degree. So, 0, 90, 90 are direction of x axis. So, direction cosines of x axis is its cosine of this angle. So, that is direction cosines of x axis are cos 0, cos 90, cos 90. That is cos 0 is 1, cos 90 0, 0. So, this is direction cosines of x axis. Similarly, direction cosines are direction ratios. So, direction ratios of x axis are also 1, 0, 0. So, for y axis it is 0, 1, 0, and for z axis it is 0, 0, 1. So, direction cosines are called direction ratios. Suppose we are given direction ratios of a line are 0, 3, 4, then direction cosines of line are. So, here A is equal to 0, B is 3, C is 4. So, A square, B square, C square root over is equal to root over of 0 plus 9 plus 16, that is equal to 5. So, direction cosines of line are A by A square B square C square, B by A square B square C square, C by A square B square C square. That is direction cosines of line R 0, 3 by 5, 4 by 5. So, that is conversion from direction ratios to direction cosines. So, this is called direction cosines and direction ratios. Next we have projection of a line on to another line. So, projection of AB on L is its drop perpendicular, that is MN. So, projection of AB on L is Mn. So, if we draw a perpendicular theta, then AC is equal to AB cos theta. So, which is equal to AB cos theta. So, projection of AB on L is equal to AB cos theta. Next we have projection of a line segment AB on L, where A having coordinate x1, y1, z1, B x2, y2, z2, and direction cosines of line L are L, which is cos alpha, M cos beta, and N cos gamma. So, AB is a line segment having coordinate x1, y1, z1, x2, y2, z2, and L is any line. So, its projection is equal to, first we have to find it, direction ratios of AB is x2 minus x1, y2 minus y1, z2 minus z1. So, as projection of AB on L is equal to magnitude of AB into cos theta. So, projection of AB on L line segment is equal to direction ratios, that is x2 minus x1 into cos alpha plus y2 minus y1 cos beta plus z2 minus z1 cos gamma, that is equal to L into x2 minus x1 M into y2 minus y1 plus N into z2 minus z1. So, this is projection of line segment and projection of line AB. So, take one example, that is we have A 1 0 2, B 3 minus 1 2, C 4 1 3, and D minus 2 1 0. So, find projection of AB on CD. So, first of all we have to find out direction ratios of both AB and CD. Direction ratios of AB is subtract coordinate values, that is 3 minus 1 minus 0, 2 minus 2, that is equal to 2 minus 1 0. Similarly, direction ratios of CD is equal to minus 2 minus 4, 1 minus 1, 0 minus 3, that is equal to minus 6, 0 minus 3. So, projection of AB on CD. So, this is on CD, that means we have to find the direction cosines of CD is equal to minus 6 divided by square root of these three numbers, minus 6 square plus 0 square plus minus 3 square, 0 by minus 6 square, 0 square minus 3 square, minus 3 by minus 6 square, 0 square plus minus 3 square. So, which is equal to minus 6 by root 45, 0 minus 3 by root 45. So, that is direction ratios of AB and direction cosines of CD. So, projection of AB on CD is equal to direction ratios into direction cosines, that is equal to 2 into minus 6 by root 45 plus minus 1 into 0 plus 0 into minus 3 by root 45. So, is equal to minus 12 by root 45. So, projection is always a positive quantity. So, it is always a positive quantity, that is equal to 12 by root 45 is 3 root 5, that is equal to 4 by root 5. So, projection is always a positive quantity, we consider this positive quantity. So, one of its application of projection is angle between two lines. Suppose L1 and L2 are two lines, and direction cosines of L1 are L1, M1, N1, and direction cosines of L2 are L2, M2, N2. So, and if theta is angle between L1 and L2, then cos theta is equal to L1 L2 plus M1 M2 plus N1 into N2. We can easily prove by using the projection law. So, this is angle between two lines, cos theta. So, if we have direction ratios of L1 are A1, A2, A3, and direction A1, B1, C1, and direction ratios of L2 are A2, B2, C2. Then, in terms of direction ratios, cos theta is, we have L1 is equal to A1 by A1 square, B1 square, C1 square, and L2 A2 by A2 square, B2 square, C2 square. Subsequently, M1, N1. So, that is equal to A1, A2, B1, B2, plus C1 C2 by root over of A1 square B1 square C1 square A2 square B2 square plus C2 square. So, this is in terms of direction ratios. So, this is angle between two lines, and if theta is equal to 90 degree, that is two lines are perpendicular, cos theta is equal to 0 because cos 90 is 0. So, this implies L1 L2 plus M1 M2 plus N1 N2 is equal to 0, or A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So, two lines are perpendicular. L1 is perpendicular to L2. If theta is equal to 0 degree or 180 degree, then two lines are parallel. Then sin 0 is equal to 0. So, we can convert from cos theta to sin theta. So, the result one will be L1 by L2 is equal to M1 by M2 is equal to N1 by N2 in terms of direction cosines, or in terms of direction ratios A1 by A2, B1 by B2 is equal to C1 by C2. So, this is angle between two lines, conditions that two lines are parallel, two lines are perpendicular. So, we can take some more examples, that is, say, take one example, that is, find angle between two lines having direction ratios 4, -1, 2 and 3, 4, 1. So, two lines having direction ratios. So, this is your A1, B1, C1 and A2, B2, C2. So, angle is cos theta is A1, A2, B1, B2, C1, C2 root over of A1 square, B1 square, C1 square, A2 square, B2 square plus C2 square. So, by putting those values, that is equal to 4 into 3 plus -1 into 4 plus 2 into 1 root over of 4 square minus 1 square 2 square 3 square 4 square 1 square. So, this is on simplifications gives 10 by root over of 16 root 21 root 26. So, theta is equal to cos inverse 10 by 21 into root 26. So, this is angle between two lines. So, you can have one more example which is mostly asked, that is, prove angle between two main diagonals of a cube is cos inverse 1 by 3. So, suppose let the cube have each side A. So, you can draw a cube having each side A. So, draw a cube and name it as O, A, B, C, D, E, F, G. So, this is a cube having each side A. Consider the axis along 3 edges: x axis, y axis and z axis. So, each side is A. Now, A point is on x axis. So, its coordinate is A, y, z coordinate is 0. So, coordinate of A is A 0 0. C is on y axis. So, its y and z, x and z coordinate is 0. So, 0 A 0 and E is on z axis. So, its coordinate 0 0 A, x and y coordinate 0. B is on xy plane. So, that means its z coordinate is 0. So, only x and y coordinate. So, its coordinate is A 0. Next, D is on yz plane. So, its x coordinate is 0. So, its 0 A and F is on xz plane. So, its coordinate is x z coordinate is A and y coordinate is 0 and G is on space. So, G having coordinate A. So, a cube have 4 main diagonals. So, what are those 4 main diagonals? One is BE. So, cube has 4 main diagonals. So, one is BE and another one is CF. Next one is OG and AD. So, a cube has 4 main diagonals, that is BE, CF, OG and AD. Now, out of these 4 you can choose any 2. Suppose we choose BE and CF. Let theta be angle between BE and CF. So, both theta is angle between BE and CF. Now, what is direction ratios of BE? Is simply we subtract the coordinate of B from E, that is 0 minus A, 0 minus A minus 0, that is equal to minus A, A. And direction ratios of CF is equal to FC, subtract each other, that is A minus 0, 0 minus A minus 0, that is equal to A minus A. And theta is angle between B and CF. So, that is cos theta is equal to minus A into A plus minus A into A plus A into A root over of minus A square plus A square minus A square plus minus A square plus A square root over of A square minus A square plus A square, that is equal to minus A square cancels plus A square minus A square divided by, it is plus minus, sign is always plus minus root over of 3A root over of 3A. So, A square cancels out. So, that is equal to plus minus minus 1 by plus minus 3, consider positive sign, this 1 by 3, then theta is equal to cos inverse 1 by 3. So, this is angle between two main diagonals of a cube. So, we can choose any two diagonals out of these four. Here we take BE and CF. Now, we can take one more example. So, take one more example. Find angle between two lines whose direction cosines are connected by the relation 3L plus M plus 5N is equal to 0, 6Mn minus 2Ln plus 5Lm is equal to 0. So, here we have to find angle between two lines having their direction cosines related by these two equations. Suppose this is equation 1 and it is equation 2. From equation 1, M is equal to minus 3L plus 5N, and putting value of M in equation 2, that is 6 minus 6N into 3L plus 5N, here minus 2Ln minus 5L into 3L plus 5N is equal to 0. So, which is on simplifications is minus, taking minus common, that is 6N into 3L plus 5N plus 2Ln plus 5L into 3L plus 5N is equal to 0. Minus cancels out both. So, which is equal to 18Ln plus 30N square plus 2Ln plus 15Ln plus 25Ln is equal to 0. That is equal to 15L square. So, that is equal to 30N square plus 45 Ln plus 15L square is equal to 0. Now 15, taking 15 common, which is 2l square plus 3ln plus l square is equal to 0, which is 2l square plus 3ln plus l square is equal to 0. Now you can factorize this term, that is 2l square plus 2ln plus ln plus l square is equal to 0. Now 2l taking common, that is 2l into l plus n plus l sorry 30n square two n common and l common, l plus n is equal to 0, that is l plus n into l plus 2n is equal to 0. So either l plus n is equal to 0 or l plus 2n is equal to 0. So L is equal to minus n or L is equal to minus 2l, but we have m is equal to minus 3l plus 3l plus 5m. L is equal to 3l plus 5n, and putting the value of L, that is minus 3n plus 5n, that is equal to minus 2n. So L is equal to minus n and m is equal to minus 2n. So L by minus 1 is equal to n by 1 and m by minus 2 is equal to n by 1. So both sides n by 1 are equal. So L by minus 1 is equal to m by minus 2 is equal to n by 1. So this is one condition, and the other condition is L is equal to minus 2n. So m is equal to minus 3l plus 5n. So that is equal to minus 6n plus 5n, that is equal to minus of minus n. So m is equal to n and L is equal to minus 2n. Again by simplification, m by 1 is equal to n by 1 and L by minus 2 is equal to n by 1. So both sides n by n 1 is equal. So L by minus 2 is equal to m by 1 is equal to n by 1. So to find its direction ratios, we have again on simplification, L by minus 1 is equal to m by minus 2 is equal to n by 1 common out, n by minus 1 root over of L square m square n square root over of minus 1 square plus 2 square minus 1 square, and L square n square is equal to 1. So L by 1 m by 2 n by minus 1 is equal to 1 by root 6. So L is equal to 1 by root 6, m is equal to 2 by root 6 and n is equal to minus 1 by root 6. So similarly here also L by minus 2 is equal to m by 1 is equal to n by 1 is equal to root over of L square m square n square root over of minus 2 square 1 square 1 square, that is L by minus 2 m by 1 n by 1 L square m square n square is equal to 1 by root 6. So L is equal to minus 2 by root 6, m is equal to 1 by root 6, n is equal to 1 by root 6. So the two lines having direction cosines are 1 by root 6, 2 by root 6 minus 1 by root 6 and minus 2 by root 6, 1 by root 6, 1 by root 6. So we have two lines having direction cosines. Suppose theta is angle between two lines. If theta is angle between two lines, then cos theta is equal to 1 by, as we have cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. So that is equal to 1 by root 6 minus 2 by root 6 plus 2 by root 6, 1 by root 6 minus 1 by root 6 into 1 by root 6. So this is your L1 L2 M1 M2 and N1 N2. So it's equal to minus 2 by 6 plus 2 by 6 minus 1 by 6. So is equal to minus 1 by 6. So theta is equal to, this is cos theta, and theta is equal to cos inverse minus 1 by 6. So this is angle between two lines. So we have direction of a line, direction cosines and direction ratios, angle between two lines. We have vector product, scalar product, and previously one thing that I will discuss, that is vector triple product. So this is, what is vector triple product? Suppose we have three vectors A, B and C vector. So vector triple product is defined to be A cross B cross C. So which is nothing but A dot B, A dot C into B minus A dot B into C. Similarly, A cross B cross C is equal to A dot C into B minus B dot C into A. So it is not associative, that is A cross B cross C is not equal to A cross B cross C. So this is a vector triple product. So, in some problem it is asked find the verify the result. So, how to verify the result? Suppose we have 3 vectors, that is A vector I cap plus 2 j cap plus k cap, B vector 2 I cap plus j cap minus k cap, and C vector I cap minus 3 j cap plus 4 k cap. And it is asked to verify the result. A cross B cross C is equal to A dot C into B minus B dot C into A. So, first of all we have to calculate A cross B, that is equal to I j k. A vector is 1 2 1 1 minus 3 4, that is equal to I cap into 8 plus 3 minus j cap into 4 minus 1 plus k cap into minus 3 minus 2, which is equal to 11 I cap minus 3 j cap minus 5 k cap. So, you have to find it A cross B cross C, next A dot C, B dot C, and subsequently the result. Thank you.